Hello everyone! Today we will talk about differentials once again. But today we will look at their structure in more detail, analyze what types of differential designs exist, how the differential is locked from a mechanical point of view, and what types of differential locks exist. We will also conduct several practical tests to determine how practical the differential is. All in order, let's get started. In the last video I explained why differential is needed in the car. If you haven't watched this video, I will briefly tell you what it was about. Differential is needed so that the car does not destroy its tires when turning, because when the car turns, the wheels travel different distances and therefore have to spin at different speeds. This is what the differential does. It sends more torque to wheel with less load, thereby making it spin faster and the other wheel slower. This reduces tire wear and also makes it easier to control car when turning. But this mechanism has its serious disadvantages, but more on that later. Let's move on to the types and structure of differentials. Well, as we remember, the structure of a standard differential is a crown gear, satellites are fixed on it, and the sun gears interact with the satellites, which are fixed on the wheel axis. When one wheel receives a higher load than the other, the satellite gears begin to spin, and thereby send less torque to the wheel with the higher load. In general, the principle of operation of all differentials is based on this mechanism. Other mechanisms are quite similar, they just use a different types of gears to reduce the friction force and increase the amount of torque transmission. In short, in general, they are all aimed at increasing the performance of the mechanism. Let's take a look at some specific examples. For example, this strange thing also has sun gears, which are hidden under the worm gears. And it also has a drive gear that transmits torque to the differential. These differentials are most often used in front-wheel drive cars and are installed near to the transmission. And now let's deal with the most interesting, limited slip differential. Why it is needed? As I said earlier, the differential has its big disadvantages, namely, if the car is stuck with one wheel in the mud and receives a small load, the differential will send all the torque to it, and not to the wheel which has a hook and can pull the car out of the strap. This problem is solved by the limited slip differential. Its design allows the car to turn normally, but at the same time, it does not allow the wheels to slip on any surface. Let's break down how it works from a mechanical point of view. We can see that the structure here is almost the same as that of a conventional differential, but here 3 new components appear, namely 6 gears with teeth in the middle, and these gears are reliably fixed on the axles near the sun gears. There are also plates with a surface of increased friction, and these plates are no longer fixed on the axle, but fixed in the body of differential itself, as a crown gear. And the third component is a spring that is fixed between the plates. Let's consider how these plates are specifically arranged. They are placed 3 plates of each type on one axis, namely behind the sun gear. They are placed in order one after the other, namely first there is a gear with teeth, then a plate with increased friction, then again a gear with teeth, and so on. What is interesting is that despite the fact that they are placed next to each other, they are fixed on the different parts of the differential. Gears with teeth are fixed on the axis, and the gear with friction is fixed on the mechanism itself, which rotates due to the crown gear. That is, they receive torque from different parts of the differential, and accordingly, sometimes different torque. The spring between them is fixed in order to compress all these plates together, so that they have a clear contact between the two surfaces. So let's consider the case when the car turns. Then some wheels will rotate more slowly than others due to the operation of differential, and these plates are still inactive. But when one of the wheels of the car gets into the mud, one wheel must start to spin. But plates with increased friction do not allow this. They provide a torque that is not distorted due to satellites, namely the one that the engine presses on the axis. Therefore, these plates rotate more slowly, and since they are very close to the plates that are fixed on the axis, they break the entire axis. In general, it can be said that when the wheel does not receive any load and starts to rotate, Then there is a sufficient difference in torque between the sun and crown gears, and then the plates with increased friction begin to work. But when the car simply turns, the difference in torques is not so great, and therefore the plates with increased friction do not work. This is how a limited slip differential works. Among its disadvantages, one can highlight the fact that its design is more expensive both in terms of maintenance and production, but in my opinion, its advantages deserve to be overpaid for it. Now let's conduct an interesting test to see how much the turning radius of a car with a locked differential will differ from a car with an unlocked one. But before that, let's take a look at how certain types of differentials are locked from a mechanical point of view. As I have repeated many times, when one of the wheels receives less load, the satellites begin to spin and transfer all the torque to the wheel that has less load. So the way to solve the problem is to simply block these satellites, so that they can spin. This is done in different ways. Either they are mechanically locked as is shown in the diagram. Some off-road vehicles have hydraulic locking systems. There are quite a few options, and unfortunately if I talk about all of them, the video will be too long. And it is not so necessary. The main thing is to understand that satellites can start scrolling, so they need to be locked. This method is called full locking, and we have already considered the incomplete locking, which is limited slip differential. Let's move on to our little test. With the differential disengaged, we can hear the tire scraping and see a very sharp increase in the turning radius. Well, that's all for now. I am very grateful to you for watching and hope that you have learned something new for yourself. If you like the video, please like it, because I worked very hard on it. Also, you can subscribe to the channel, because we have a lot of interesting car content ahead. Thank you again for watching, see you soon!